so let's talk about scientific notation. Now there's a generic format to it that consists of two pieces. So I'm just going to write a number here, generic number in scientific notation. The two parts are the mantissa. That mantissa does have rules. Only one number to the left of the decimal is allowed. All the numbers to the right of the decimal, you have as many as you need to have the correct sig figs. And then you also have this number over here that's the multiplier. This is the number that is used to get the scientific notation value back to the original number. All right, so let's look at a few examples and see what trends we can draw from this. For our first number, right here, I'm going to write all the significant figures, and then only one number to the left of the decimal. So I put the decimal there. I have base 10 raised to whatever power is necessary to get this scientific notation value back to the original value. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Raised to the 10, but I notice that I have to take that 3.4 and divide it by 10. To divide by 10, I have a negative exponent. For the next number, write all the significant figures. 1, 2, 3, 4 times 10 to the negative 4. Now I have a different sort of number. This number is larger than 1. I can see the exponent. 1, 2, 3 times 10 to the 3. All right, and the next one, this I want 3 sig figs, so I don't include the 0. 1, 2, 3. And for the next one, I want 4 significant figures, so I do include the 0. 1, 2, 3. And notice that didn't involve the powers. It didn't change it at all. Just changed the mantissa for sig figs. So these are the ways to convert a value into scientific notation. Looking back over this, I noticed that every time I have numbers less than 1, I end up having a negative exponent. So this negative exponent must mean or indicate a small number. So negative exponents in scientific notation indicate small numbers, less than 1, and positive exponent indicates large numbers. Great. So now I can use that to my benefit here. I see that I have a plus 6, so it must be a large number. 1.020 times 10 to the 6, I'll move it to the right, 1, 2, 3, 4, 5, 6. So that is 1,020,000 is the value. And I'll keep in mind that it has 4 significant figures, because that's how many sig figs it had in the mantissa. For the 5.25, it's a negative 3, so it's a small number, less than 1. So 1, 2, 3, I move it to the left for that negative exponent. There we go. So I have 0.00525. And for the negative 9, again, I have a small number, less than 1. 7.0, I'm going to need more space than that. 7.0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, just barely fit it in. And I should have 8 zeros, and indeed I do. Again, this is for 2 significant figures, just to remind myself. So looking at scientific notation, we notice the trends. 1 digit to the left of the decimal, and then the exponent identifies whether it's a small number